Okay, so in that video, that was an example of an inelastic collision, which we learned in the momentum and impulse unit. And basically, what's happening is some mechanical energy is being transformed into heat energy, because that's what happens in the inelastic collisions, which causes either two colliding objects to start out separate and stick together, or start out stuck together and then finish separate. So in that video, the example that I chose to show was when they start out separate and stick together. And the equation for that, to find out, any given value, say you don't know the, mass 1. Say you don't know the mass of the first colliding object, so we'll just call that mass 1. And then for the second colliding object, we'll just call that mass 2. And the same for their velocities. So the velocity of the first cart will be the v1, which will correlate with m1, and then v2 will correlate with m2. So the equation for that collision is m1 times v1 initial plus m2 times v2 initial, and in parentheses, you put that in parentheses, and then that all equals, in parentheses, m1 plus m2 times v final. And so that, you use that equation, you plug in your values, and then if you need to use algebra to solve for any value, you can. And just for the other types of collisions that can happen between two colliding objects, there's the simple elastic collision, and the only type of elastic collision is when the objects start out separate and finish separate. And what happens is they're bouncing off each other, essentially. So it's pretty straightforward. That's just what happens in the collision. And if you were given that scenario and you had to find any given value, the equation for that collision is m1 times v1 initial plus m2 times v2 initial, and then all that in parentheses, and that equals m1 times v1 final plus m2 times v2 final, not all in parentheses, and then you can use that to solve for any given value. And then the last type of collision that you can have is another inelastic collision, except this one is when they start stuck together and finish separate. So that equation is, in parentheses, m1 times m2, and then times v initial, equals m1 times v1 final plus m2 times v2 final. Like I said, in the first one, the m1, v1, they're all the same. So m1, v1, m1 and v1 are for the first object, and m2 and v2 are for the second object, in terms of, the ones that are involved in the collision. And the reason you see patterns, there's patterns I should explain. So, for example, in the inelastic collision, the first collision I talked about, the one that you saw in that video, the reason that there's a m1 plus m2 in parentheses on the opposite side of the equation times v final is because, if you think about it, they're starting separate. So on the left side of the equation, you can almost see that as your starting point. So you're starting with m1 times v1 initial plus m2 times v2 initial, because it's the initial point of the start of the collision, which is when they're separate. So that's why they're separated by that plus sign. And then they equal the final part of the collision, which is when they're stuck together. So that's why you have m1 plus m2 in the same parentheses times v final. So it's not m1 v1 final plus m2 v2 final, because that would be them starting separate and ending separate, which is what you see in the elastic collision. This one, they're starting separate and finishing together, and that v final on the outside is what shows that. And then it's basically the opposite for the other inelastic collision. They just start together with m1 times m2 times v initial, and then equals m1 v1 final plus m2 v2 final, which is when what you use when they're separate. And so that is all I have to say about that collision, and that is what happens.